All right, so this is the volume of revolving a shape around the x-axis. I'm not going to revolve around y-axis or other things because they get more complicated. So again, very simple formula, like I showed in class. I'm going to put the pi out here. Remember, as you take a shape and you start spinning it, right? You have a shape and you spin it around. It creates this solid thing that has little circles in it. Not donut, but it's solid. So you have little areas there of circles. This is why the pi is there, and it's pi r squared. And r in this case is the function. Don't forget your little dx. So all I have to do is square this, integrate it between whatever numbers I tell you. So if I want the volume of the graph of this thing revolved around the x-axis between 1 and 3, I'm going to put 1 and 3, keep my pi there. It's just more convenient to have it outside the integral. I have to take that and I have to square it. And again, I'm going 1 to 3. This one's pretty easy. I picked a nice one to do for the first one. That's what was the whole point. Now you got to be careful when you square this though. When you times it by itself, you have to square the 2 also. So again, I'm going to put my integral. I'm going to put the pi, put 1 and 3. I'm going to get 4. Now when you square this, it's very simple. If you ever see a radical in these questions, I just handed you a big gift because the radical and right square root and square cancel each other out, and you just get what's inside there. Always, always. So seeing a square root on these questions, you get a big smile on your face because you're squaring. So the square root will always go away. So now you just integrate. I mean, I'm going to distribute first to make it, again, keep my pi. It's very easy to lose the pi. Remember, it's a volume, so it's going to have pi. So you get 4x plus 4 dx. I'm running out of room, so I don't need the formula. I'll be horrible and I'll do this. I'll do it here, then I'll plug in up there. So I'm going to add 1 to the power, divide. So again, I'm going to keep the pi there. So I'm going to get 2x squared, right? Power becomes x squared. And then here you just add on an x. And you're going to evaluate it from 1 to 3. I'm just going to write it again up here and then erase. So it's easier to do. Now, again, a lot of students write these very incorrectly. You have to make sure that you write everything properly. You have to write the integral symbol until you have found the antiderivative. Once you do that, you have to write this thing. This line means that you are evaluating this at those numbers and you're going to subtract them. So it's not, these aren't bad to figure out. So let's see. I'm going to keep the pi again. I'm going to plug in 3 and then I'm going to plug in 1. So I plug in 3. Then I plug in 1. I mean, I generally try very hard to give you nice numbers to plug in. 3 squared, remember, you can't hop the fence with the power on. You have to do the power first. So that's 9 times 2. 18. 4 and 3 make 12. Over here again, that's 1 squared times 2. 4 times 1. It's pretty easy. And again, you got that pi hanging out and waiting for the number. This is 30. You're going to subtract the 6 that's there. Get that pi. So you get 24 pi. I'm pretty sure that was the right answer. I don't have any answers on my sheet. I only have the questions, no answers. So I assume it's right. I mean, if I did it wrong, I did it wrong. I'd have to fix it. All right, so again, square the original function. Simplify it a little bit if you need to. Do the antiderivative and then plug the numbers in. I mean, it's very straightforward. It can be, they get a little more complicated, so I'm going to do some more examples of it. But really, it's not that bad. All right, so this is one where it gets a little bit more complicated. We're going to revolve that shape around the x-axis, create a solid. We're going to find the volume of it. So again, you write your formula. I like to put the pi first. I mean, I had it there in class, but it doesn't matter. From 4 to 9. Now there's a reason I chose those numbers. You'll see in a minute. So what that is, right? This is important. If you can't, from Calc 1, you were constantly taking derivatives of things that look like this. So you had to constantly write them as exponents to use the power rule. So this is a 4th root. So, right, and there's an invisible 1 there. The 1 always goes on top. Whatever power is there will go on top, but the root always goes on the bottom. So now I have 1 over that. So again, you would not be able to take a derivative of this with the power rule unless you moved it up. So that's exactly what I'm going to do here. I'm going to write it as x to the minus 1/4 squared dx. So I did a little bit of work on the side just to convert my radical into an exponent that I can use. Now, you have to remember again what the rule was. When you raise a power to a power, you multiply them. This is x to the 6 because you do 3 times 2. So yes, it can be tricky with the fractions, and people do it wrong. That's why I'm going over it. So I have to multiply these together. But that just puts the 2. I mean, you could just put 2 into 4. That's what I would do. So you get negative 1/2 when you square it. And again, you do this little work on the side. It's not necessary to go crazy and write all these steps for something very simple. All right. So, but I do want to see that that you get 2/4 and you make it a half. So it's negative 1/2 power. This is very, very easy to find the antiderivative of, right? You're going to add 1 to that power. And again, I'm going to do this on the side. There's no reason not to. I'm going to add 1 to the power, which is 2/2. So my new power, right? Same bottom, subtract the top, so you get 2 minus 1, so you get a half. Right? Negative 1/2 plus 1 is positive 1/2. Now I'm going to flip that over, put it in the front. Right? That's what I taught you to do. If you want to do this dumbass thing, fine. Do this dumbass thing, whatever. You can end up with the same thing I do, and I could do it a lot faster than you because I do it in an easy way. So my antiderivative, should have wrote it over here, is that, let me put my pi. You know what I'm going to write 2 pi. I'm going to times it by pi, so it's easier for me to do. I don't need that anymore, right? So find the antiderivative of that. You added 1, you flip the power, put it in the front, you got that. I still have my pi there, so I just put it with the 2, right? They're both a constant, so you just leave that in the front. And then I'm going to evaluate that now. I think you understand why. I mean, I have to give you perfect squares. 1/2 power is square root. So you're doing 2 pi radical x, right? Now you want to put the radical back. I see a lot of students when they're computing this, they'll put 9 there. And then they go, oh, the half of 9, it's 4.5. This is just complete stupidity, all right? So I'm putting the radical back for myself. Now I'm going to plug in, right? I'm going to take 9 first, take the square root of that, minus, this is why it's convenient to put the pi with the 2, so you don't have to do it at the end. It's already there, right? Plug in the 9, plug in the 4. Square root of 9 is 3, times it with the 2, you get 6. Square root of 4 is 2, times it with that 2, you get 4. So you have 6 pi's, and you eat 4 pi's. That leaves you 2 pi's. That's a lot of pi's. So again, rewrite that so it has a fractional exponent, square it, which means you multiply the powers together. I found my antiderivative, add 1 to the power, divide by the new power, or flip it over, whatever you like. Keep the pi there. It's very easy to lose the pi. Happens to me too. Sometimes I forget to write it. I write it at the end. I see students do that all the time. And then plug the numbers in, right? But you wanted to. This is not a trivial step right here. If you're going to compute this, it helps to write it in the way that you're used to seeing it, which is with the radical. So that's exactly why I did that. I don't, students, I see it all the time. Like I'll have 9 and I will not pick 4 because half of 4 is 2 and the square root of 4 is 2. But I might pick a 16. And then I'll just have people tell me 8. Like 16 to the half, it's 8. I will make sure, because I know what students do. I know that they just take the number there and they just cut it in half. So put the radical back and then compute it that way. All right, I'm gonna do another one. Okay, now I realized on the last one that I kept the number 1 there when it was actually number 2, so whatever. So I jumped to number 4. Now, if you ever see that I gave you a 0, I just gave you a really, really nice gift. This one's a little more complicated because the squaring is a little bit more complicated, but it's not that bad. So again, the volume is pi, integral from a to b, which in our case is going to be 0 and 1. It's not going to get any easier than that to plug in. The original function squared dx. Now again, you're in calculus 2. You are in calculus 2. I do not expect dumbass things here like telling me that this is 4. I mean, now I see some crazy crap here. I see C-students tell me it's 6x, or it's 6x squared, or it's 9x, which is more reasonable. But the usual thing I see is this. They'll just square that, square that. That's not the way it works, right? I like to do it on the side. When you square something, it means you times it by itself. Now, I am going to rewrite it in a different order after I do this, because it's going to come backwards. 2 and 2 make 4, right? You do your rainbow. Your inner, whoops, helps if I do 3 times 2 correctly. 3 times 2, 6. Outer, right? That's the rainbow. So you get negative 12, x is in the middle. And then negative negative is positive. 3 and 3 is 9. X and x squared. Now I don't want to write it backwards. I always want to integrate from highest to lowest power. 2, 1, none. So that's exactly what I'm going to do. All right. Well, let's see. I barely fit my pi in there. So from 0 to 1, pi, the function squared. I did it on the side. I'm going to write it in highest power first. Just be careful. Make sure. Positive 9, negative 12x, negative 12x. Positive 4, there's no negative there. 2 times 2 is not negative 4. So it's positive. And then I put my dx, the right proper form. Right? I'm going to calc 2 now. It's the big time. So you got to write it correctly. I'm going to find the antiderivative one at a time. I'm going to keep my pi there for convenience. And then I'm going to just integrate, right? Add 1, so it becomes x third. If I flip that over and put it in the front, well, you just divide 9 by 3. It's the same thing, right? 3. Please do this. I am seeing way too many people add 1 to the power, and then, they're leaving it like this, which is ridiculous. I mean, if you're not going to tell me what 9 divided by 3 is, I mean, you're just making it more complicated. Here, you're going to add 1 to the power, which makes it x squared, right? Divide by that power, or flip it over, put it in front. So that's negative 6x squared. And then the 4, right? It doesn't have an x, you just throw on an x. That's the integration technique. And I'm going to evaluate all that at 0 and 1. Why is that awesome? X, 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 and you're plugging in 0. So this really is me just plugging in the number 1. Could not get any simpler. So, I mean, I was even though it comes out a little bit nasty here, when you plug in 0, you get 0, 0, 0. So you get a big ass 0 over there. So all I have to do is compute that number and times it by pi. 1 cubed is 1 times 3. 1 squared is 1 times negative 6. So you get negative 6. I don't like the way my 3 looks. I'm going to do it again. Plus 4. Wow, this just comes out to pi, huh? So you have $4, $3 is 7. 7 minus 6 is 1 times the pi. So the volume is just pi. Not that bad. So again, square this. I did it carefully. I did it on the side. I got that. I wrote the powers from highest to lowest. Found the antiderivative. 0 is a joke to plug in. All you really had to do is just plug in 1. And again, just be careful with it. Right? You watch your signs, watch the powers. Don't do anything crazy. Again, is it super difficult? No. But, there are places you can make errors if you're going through it carelessly. That's why you want to take your time. You want to watch what you're doing. And then, double check it real quick and just make sure. All right, so now I want to do the one with the trig function because I know it scares people. All right, so this is the 5th one. Now you have a trig function. And again, people, as soon as they see a trig function, they start to freak out. It's going to be complicated. We're going to do a lot of very difficult things with trigonometry in Calc 2. And this isn't it. So again, volume, you're going to take the function, square it, dx. Now, there's nothing special to do here, right? When you square secant, you get secant squared. Now, pi over 6 is 30 degrees. If you want to write 30, you can write 30, but I prefer that you leave it in radian mode, right? I mean, you could convert it into degrees. And I'm going to use this number when I find the value on the chart. So, very easy, right? Pi, function squared. Now, you're looking for the antiderivative of secant squared, which means I need the dude whose derivative is secant squared. And, you should have that memorized. I'm going to keep my pi there. So when I integrate secant squared, I get tangent. Our good old buddy tangent. Nothing crazy. No squareds, no nothing, right? The derivative of tan is secant squared. So that's my antiderivative of secant squared. Now I have to compute that from 0 to 30. pi over 6. Now, I didn't give you the value for tangent of 0, but if you remember that tangent is sine over cosine, it's actually quite easy to do. All right, so I'm going to have my pi. I'm going to do tan of pi over 6, and I'm going to subtract tan of 0. But you'll see this is actually going to be really simple. The tangent of 0 is the sine of 0 divided by the cosine of 0. Now these I did put on the trig table for you. The cosine of 0 degrees is 1, which is good because you can't have a 0 there. The sine of 0 is 0. One of them is always 0 and one of them is always 1 or minus 1. Like on the 0, 90, 180, 270, 360 when you go around the unit circle and find those values. So the tangent of 0 is just 0. You would have a very big problem here if I had put something like 90 degrees there. Tangent of 90 does not exist. It is undefined. So this integral, you wouldn't be able to compute this integral. It would be BS. But in this case, I made sure I gave you an angle that actually works. Now, the tan of 30 is on the chart. It's 1 over radical 3. I gave you the values for 30, 45, and 60, and that's why I gave them to you. And then you times it by pi. So that's going to be gone. So you just get pi divided by radical 3. There's no reason to do anything crazy. I mean, you could do sine 30 divided by cosine 30, but why would you do that if I already gave you the value of tangent, right? I mean, if I only gave you sine and cosine, then you would do that. But I gave you the values of tangent for 30, 45, and 60. 1 over radical 3, it's 1, and then it's radical 3. So there you go. There, I mean, when we first look at it, it looks complicated. You see secant, you're like, I don't know what to do. But when you square it, you get that is the derivative of tan that you got. So I mean, it couldn't be more straightforward. And then this, the plugging in, that's the whole reason why I gave you a cheat sheet with all of the values, because I don't want you to get bogged down because you don't know how to do these things at the end of the problem. All right, so I think that's good enough. So hopefully that helps.